the next task that we want to do is to draw a Gantt chart from the activity network. The first thing is to draw a time scale. So we look at the biggest number here in the activity network, it's 13, and I need to go from 0 to 13. Now this particular Gantt chart is not under any constraint of how many workers were given for the project, so we can use as many workers as possible. And when we're drawing that, we'll start first of all by looking at the critical path. So the critical path is AC, and we put activity A followed on to activity C on the same line in the Gantt chart, something like that. I do suggest using a ruler for this, but I'm going to draw them relatively quickly. And then activities B, D, E, and F, I'm going to put those below each other on the Gantt chart. And from those, then we'll see, can we squish them onto fewer lines? And if we can squish them onto fewer lines, we can use that to determine the minimum number of workers required to complete the project on time. In other words, the number of workers, or the minimum number of workers needed to complete the project in 13 days. Okay, how do we do the non-critical activities? Well, we look at the values before and the values after, the top value before and the bottom value after, or smallest value before, largest value after. And B has to occur between 0 and 5. So there's a bit of a float here as well, in that B can occur somewhere between 0 and 5, but it only takes 4 days to complete. So I need to put B in there, and B is going to be 4 days long. As we can see then, this section here is the float for B. So B could start at day 1 and finish at day 4, or we could shift it along by a float of 1. It could start at day 1 and end at day 5. So this is movable, that bar is movable within that range. Let's take a look at E. So again, we're looking at the small number in front, the large number at the end. So E can occur between 4 and 10. But E is only 4 days long. So I'm going to draw it in like that. E4. And again, like a slider within a fixed area, E could be slid across. This here then is the float of E. We'll do the same with D. Small number at the start or before the arrow, and large number at the end. So anywhere between 4 and 13. D can take place. D is of weight 8. So we're looking at that. The float of D then is 1. And the last one is F. Small number at the start of the arrow to the large number at the end of the arrow. So 8 to 13. And then we put in the box representing F's actual weight, which is 3. Do you need to draw these actual solid boxes at the start of the dotted box? Not at all, but this is the convention in my class. So F and 3. That's your Gantt chart completed. Now we've 2 other things to do here. The first one is to answer the question, what must be happening on day 6? And the final question I'm going to answer is, what is the minimum number of workers needed to complete this activity on time, so within 13 days. All right, so this one to start with. Day 6 is here. Draw a line down. And we're asking ourselves, what activities must be happening? In other words, the red line goes through A, it goes through E, and it goes through D. Now what you're asking yourself is, which ones can't be moved out of the way? So if we were to slide E up, E would still be going through the point 6, so E has to be occurring at that time. You could slide D up, the line would still go through D, and the line has to go through A because it's fixed. So the activities that must be happening are A, E, and D. Now, for the third question, question we want to answer, what's the minimum number of workers? And that minimum number of workers is assuming the duration of the project is 13. So we're basically asking ourselves, how many lines can we squish these onto? Well, if we look at it, we could squish E up, then E would follow on from B directly. We can't squish D up, but we could put F on the same line as that. So B, E, and F could occur in the same line because there'd be no overlap. D would occur on its own, and that tells me then there's a minimum number of workers, which is 3 in that case. Now there's also a calculation here by which we can get the minimum number of workers, and it's referred to as the lower bound. And we'll do the lower bound now in the next video as well. So the lower bound is calculated by getting the weight of the critical activities and dividing it by the total weight of all activities. Alright, so we need to scroll back up a little bit. The critical activities are A and C, so that's 13. And then if we added 7, 6, 4, and these as well, we'd end out with, so that's 17, 25, 25 and 9 is 34. That gives you roughly 2.8. That tells me that 2 workers will not be enough to complete the activity, but for the lower bound we always round up, and that's telling me a minimum of 3 workers is required to complete the activity. So what have we done here? We've worked it out that we need 3 workers to complete the activity based on the compression of the Gantt chart, and we've confirmed that with the lower bound value. In the next video, we look at another example and we'll do the exact same thing.